Starting with the conquest 12, which is related to Bernoulli rate and modes, as well as the reversible reactions. Um, in the first question, ammonia is made in an industrial process with nitrogen. The equation for the reaction is shown, and the forward reaction is exothermic. Means when this reaction will occur, heat energy is given out. State the effect, if any, on the position of equilibrium. So remember for exothermic reactions, whenever a chemical reaction is exothermic, what will happen if we increase the temperature? This is a fixed effect, like it does not depend on any other thing other than the nature of a reaction, whether it's exo or endo. So for exothermic reactions, if we increase temperature, where the balance or equilibrium will shift, it will shift towards the left hand side or it will shift backward. And if we decrease temperature or reduce the temperature, where the equilibrium will shift towards right, or we can also say forward. So state the effect, if any, on the position of equilibrium, and which of the following, like the following changes were made or are made. Temperature is reduced. So if you reduce the temperature, what will happen? Equilibrium will shift towards right. How you score to, like there are total 4 marks, 2 mark for effect of pressure, 2 mark for temperature. So 1 mark, it will shift towards right or shifted towards right. And second mark is for reason because the forward reaction is exothermic. So as the forward reaction is exothermic, that's why the equilibrium or the balance has shifted towards right hand side. What is the effect of the pressure? Remember, when we increase the pressure, equilibrium will shift towards side. The effect of the pressure depends on the equation itself, the number of moles of the gaseous reactant and product. So if we increase the pressure, equilibrium will shift towards side of less moles. And if we decrease pressure, equilibrium will shift towards side of where more moles of the gas or gaseous moles are there. So when we check the number of moles of reactant, here we have 1 and 3, so total 4 moles are there. When we check the moles of a product, we have 2 moles. So if we increase the pressure, equilibrium should shift towards the right hand side. But if we reduce or decrease the pressure, equilibrium will shift towards side of more moles. So the side of the more moles is towards the left hand side. So reducing a pressure or decreasing a pressure, it will shift towards the left hand side. And the reason you will mention on the left hand side, there are more moles. So shift it towards left. Because there are more moles in the left hand side. So in decreasing pressure, shift the equilibrium towards side where we have more moles. And increasing the pressure, shift the equilibrium towards side where we have less moles of the gas. So 1 mark, like how the marks are distributed, 1 mark is for mentioning shifted towards right, 1 mark is for forward reaction is exo. Here shifted towards left, 1 mark, because there are more moles on the left hand side. Explain in terms of particles what happened to a rate of a chemical reaction when a temperature is reduced. So this is related to rate or a speed of a chemical reaction. So what will happen when we decrease the temperature? The speed of the molecule decrease. And when the speed of the molecule decrease, what will happen? They will move slower. So they will have less collisions. And we'll have smaller proportion of the particles. With activation energy. So the proportion of the particle with activation energy, that proportion will also decrease. Or less collision. You can mention these points like less energy, less proportion of particle, or few successful collisions will be there. How the marks are distributed, one mark is for mentioning the rate will decrease or particles have less energy, it's the same thing. One mark is for mentioning less collisions, one mark is for mentioning less particles with having energy more than activation. If we increase temperature, speed of particle increases or rate increases, more particles, more collision, or greater proportion of the particles have energy more than activation. So this was a pop quiz which was mainly related to reversible reaction and reversible reaction.